Well, in about 10 minutes.
10 minutes, okay. I
Yeah.
got some time to finish up.
I give you 10 more minutes, that's right. Okay, so let's just talk about the solution to the quiz to start with. But before I do that, let me begin with a word of prayer. So, Heavenly Father, we thank you again for this time we have to meet together and to study your creation. Just pray that you'd be glorified in what we do and that we will all be able to prepare for the test on Thursday this week, Lord. In my prayer, Lord Jesus, amen. All right, so the quiz problems I seem to have covered up with the projector. Let's try this again. So number one, the graph is got a horizontal asymptote at 2, and it's basically a volcano. So you take the volcano graph and you shift it up so the graph looks something kind of sort of like this. And let's see here, have I answered the question? Graph, label any horizontal or vertical asymptotes. Okay, so y equals 2 is a horizontal asymptote. What's the vertical asymptote here? 0, right? 0 is the vertical asymptote in this one. So just as soon as I find a marker, so here, x equals to 0, vertical asymptote. All right, so that's number one. Number two, that factors, right? So you've got y is equal to x plus 3 times x minus 3 divided by x plus 3 times x minus 4. So this reduces to x minus 3 over x minus 4 for x not equal to minus 3, right? So there is a x-intercept at 3, 0. There is a vertical asymptote at x equals to 4, and there's a hole in the graph at x equals to minus 3. More particularly, it's at minus 3, the reduced function at minus 3, which is actually minus 3. Plug in minus 3 into that, I get minus 3 over minus 3 minus 4. So the hole in the graph is actually at minus 3, 6/7. So there's where the hole in the graph is. Yep.
Would you accept just x equals minus 3?
I would for this one, but if I reword, like on the test, in the past, I have said more specifically, I said, find coordinates. So if I had done that, then I wouldn't, but since I didn't, I will accept minus 3 for the hole in the graph, yeah. But it is important to me that you learn how to figure out where the hole is. So this isn't just me trying to impress you or something. It's probably not the way to impress students anyway, but where was I? Oh, yes, 3. Number 3, if you look at, we have y equals to, going back to what we started with, it's x squared minus 9. And if I multiply out the denominator, I've got x squared minus 7x plus 12. Is that right? Minus 12, right? So this is approximately x squared over x squared if the absolute value of x is like much, much greater than 1. In other words, this thing, it tends to 1 for really large values of x or really large negative values of x, which is to say the horizontal asymptote for this one is y equals to 1. So now you could kind of see that by putting in, if you plug in like 10, you'll get essentially 100. Well, put in 100, you get like 10,000 divided by 10,000, and there's some the other terms are practically negligible when you get to like 100. But there's a theorem that you can remember, put on your formula sheet if you like, and here's the theorem, guys. if we have y is equal to ax to the n plus dot, 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 plus a0, and we've got, say, b x to the n plus lower order stuff, all right? Then this, if we look at this graph, then y equals to a over b is the horizontal asymptote for this. If you have, so this is just a fun fact, all right? So if you think about examples we've worked, you've seen that in a few different examples, but that's basically what happens. If you have the same degree in the numerator and the denominator, the ratio of the leading coefficients will be the horizontal asymptote. That's what the graph has to go to eventually. Now, if the degree of the denominator is larger, then it's what we call the proper rational function, and the horizontal asymptote is just y equal to 0. In other words, eventually the denominator wins. But that's pretty much it. Any? Oh, just lower order stuff. So if you want me to be more pedantic here, we could do like a n minus 1, x to the n minus 1, plus dot dot dot, plus like a2x squared, plus a1x, plus a0. So the dot dot dot, what I was trying to indicate is lower order, lower degree terms. So the leading term in the numerator and the denominator is the power n. It's like I have degree n upstairs, I've got degree n downstairs. In that case, the ratio of the leading coefficients is the horizontal asymptote. But it has to be in this format, right? Like, so that worked for this one after I multiply it out, because the x squared's the biggest thing upstairs, x squared's the biggest thing downstairs. This one here, if you make a common denominator, what would it be? If I put that as one single fraction and undid the plus 2, what would it look like? How can you write that as a fraction? I heard 2x squared over x squared? Is that right? Yeah, we'd have 2x squared plus 1 over x squared, right? So in this case, if you look at my fun fact theorem, we have same order above and below. The ratio of the leading coefficients is 2 and 1. So the horizontal asymptote is 2. But this one, you can also just see it. If you plug in a really large number, what happens to 1 over x squared? It's nothing. Nothing, I say, compared to 2, right? So that 1 over x squared is negligible for like large magnitude numbers, which means the horizontal asymptote is 2.
That one has a lot more sense than the ax and minus 1.
Well, yeah, this is the general theorem, so it looks kind of scary, but yeah. You can ignore it if you want. As long as you can work problems like I had in the quiz, you should be okay. Then you're what? Then you're in trouble. All right, well, I should probably go ahead and collect everybody's mission at this point. Everybody got their name on there, and if you need a stapler, there's one here somewhere. Where has it gone to? There. Who needs the stapler? Don't tell my physics class. I don't bring a stapler for them. So you guys, this is our secret, all right? I can't. I feel like I shouldn't tell you that.
You should. I gotta take physics.
You got to take physics? Oh, probably not the one for me, though. I usually teach physics. I don't usually teach physics, actually. But at the moment, I'm teaching physics 231. So you probably need the 201 one, right? Yeah. I taught that in the summer once, 201, 202. That was kind of an adventure. Actually, they were pretty good students. They're actually like way better than the engineers. Anybody else need a stapler? So like the summer class I taught, it was like there were a lot of pre-med students. You know, they care about their grade a lot. And they did this weird thing. They like worked on their homework before it was due and asked me questions about it. It was really strange. Like they studied. And so like the engineers have, by and large, an aversion to working ahead. It's a very proud virtue to procrastinate one's homework until the day before it's due, and then to finish it. If you can finish it in like the 30 seconds before class, you have impressed your friends, right? Like that's where the real street cred comes from. Something like that. Whew, man, this is a lot, isn't it? Actually, this is not too much, but hopefully it was enough for you to understand the material, right? If you can grade them for me. If this wasn't enough problems, then you should really, of course, work more from the book or something, right? Which is why I have recommended problems for you guys. Any questions about anything? Well, I'll show you I'll show you the solution here. So I have good news and I have bad news. The bad news is that my solution is not complete. The good news is I should have it complete before the end of the day. I just need to keep writing. Come on, come back to me. All right, computer. Let's see here. So this may be ancient history because you solved these problems 3 weeks ago or something, right? Others of you are like, well, that was yesterday about 5. I don't know. It depends, right? But let us talk through these. Now, let me just interrupt myself. If there's a particular problem later in the homework that you need to see me work out, request it. We can do it now. I only get up through about the halfway mark in the mission at the moment on this overhead. All right? So let me go somewhat quickly through here. Listen, there is definitely two reasonable answers here. Maybe there's more. So like, I'm going to give this to the grader, right? And she's probably going to grade on the basis of what I have written here. And she might count you wrong. It could be that you're right and she just didn't see it. Like if you feel in your heart that you're right and the points have been deducted or something, you just come and talk to me, all right? But simplification's always a little bit treacherous for grading because, you know, beauty's in the eye of the beholder. So anyway, so there's that. This one, so the basic theme here is make a common denominator and then multiply things out, see if things cancel. And sometimes they do, right? The x squared and the x squared cancels. Here, there's a bunch of stuff that cancels, like the x plus 1 and x plus 1 cancel, x plus 3 and x plus 3 cancel there. Right? So there's that. I think I need to zoom out. I get it. If you touch the wrong button up there, then we'll be... oh, what? Whoa. What? What happened here?
I don't know.
Was that me? That might have been me.
I
See,
think
It was, yeah.
so it's probably me.
Yeah,
See,
I definitely
it's,
didn't do all what you're doing right now.
yeah, there's no hope for you because you had to actually rotate it 90 degrees before it could do it. So you could have been at that all day long and never would have worked. There we go.
Came back and said, whoa.
Yeah, that was my fault. So anyway, all right. So here, as you can see, these cancel and we're left with that. I mean, I think that's, if you multiplied out the numerator, that's still correct, right? Fine. This one here, the way to clear out a fraction like this is to multiply by x plus 1 upstairs and downstairs. When you do that, it clears out the fractions that are present in the numerator and the denominator and gets you to here. Then that simplifies to this. All right, let's see here. What else do we got? This one here, the common denominator is x plus 3 squared. So if you just cross multiply here, you would make it more complicated, right? Like it would be a bad move to just multiply this over here and that over there, because if you do that, then you're going to have a cubic. It would greatly complicate things and you might not see how to simplify back. So an important principle is if one of your denominators has a factor of the other one, then you just want to find sort of the least common multiple of the denominators to make the common denominator. Just like numbers, right? If you're adding a quarter to a 16th, you don't turn them into 64ths, right? You just turn the quarter into a 16th. You know, a quarter is, 16 64ths, so that kind of thing. All right, I shut up. This one here, if you factor this, when you multiply, this cancels that, and that cancels that as you distribute. And then you get x minus x and 2 minus 1, and the answer is 1. So every so often I find an answer that I feel like there's really not any debate about what the correct answer is. This one here, I think the answer is 1. Like, this is clearly the answer. I mean, I don't think it can be more beautiful than that. What? Oh, yep. The next one, if you're faced with something like x over x minus 3, what you want to do is multiply both sides by x minus 3. And then you've got a linear equation, which then you isolate x, divide by its coefficient, and you get x equals to 4. Right? There's that one. This one, again, what I did was I multiply x plus 3 over here, and I multiply x over there, which gets me to here. I call this cross-multiplying, right? And when you do that, you get yourself a quadratic. Now this quadratic here, it's kind of, it makes you feel like maybe you could factor, but if you fuss around with it for a little bit, it just does not factor nicely, right? So I completed the square because, as you know, a day is better once you complete the square. So, and that gets me x minus 1 squared equals to 13, and then square root that thing, and you get x minus 1 plus or minus root 13, which gives us their 2 answers here. There are 2 answers. Don't have any whiteout at my desk right now. My apologies for this mess. But so if you come across something like this in a dark alleyway, the first thing you want to do is pull out your x squared and hit it in the face, or all 3 of its faces in this case. And as you distribute that blow across the equation, x squared cancels with x, or with x squared, and leaves you with, again, a quadratic equation, which this time we can factor, right? X minus 1, x minus 3, and so the answers are 1 and 3. Problem 37. So the next bunch of answers are inequalities. The basic problem with these is you have to have it in the right format. So if I start you out with junk less than or equal to 2, the first order of business is to reformulate it so that it's stuff less than or equal to 0, or stuff greater than or equal to 0, or less than or greater than. You want to change it to an inequality that is, measured against 0. Because 0 is where we can set up the sign chart for, and everything works out nice. And so my first order of business is to bring the 2 to the other side, as I did here, and then I make a common denominator by multiplying 2 by x plus 3 over x plus 3, which then simplifies to this. I look at it, I like, okay, my critical numbers are minus 17 and minus 3. Which one comes first? Well, minus 17 is to the left, right? So put them like that. I plug in some points. I get minuses, pluses, then minuses. And so I'm trying to solve less than or equal to 0, so I'm looking at either end, all right? So that's 80% of the solution. The last 20% of the solution concerns whether or not we include or exclude endpoints. So you guys tell me, why is it that I have put minus 17 into the solution set, but I have excluded minus 3? What's the difference? Yeah.
Because x plus 3 is on the bottom.
Right.
Yeah.
Right, x plus 3 is in the denominator, so if we put in minus 3 into the expression, we get division by 0, right? Which is no allowed. So on the other hand, you can put minus 17 into it, and that just gives you a 0 in the numerator, which is fine. The same logic applies to all the next problems. You just throw out anything that gives you division by 0. All right? So for this one, is even easier, even though it's harder, because it's already factored, right? I mean, it's already measured, it's already set up against 0. So I just make my sign chart. My critical numbers in this one are 2, 6, minus 3, and 4. So put those in order. Minus 3, 2, 4, 6. Plug in some points. I get pluses, minuses, pluses, minuses, pluses. Because every one of these has odd order, so it always flips the sign. And then I'm trying to solve greater than or equal to 0, so I look for the pluses, right? So that gives me minus infinity to minus 3, 2 to 4, and then 6 to infinity. I include the minus 3, and I include the 4, because those are in the numerator. That does make the numerator 0. I exclude the 6, because that would give us division by 0. And I exclude the 2, because that would also give us division by 0. Any questions? We use this same strategy to solve all of these inequalities. What's the method? Take your rational function, factor it, identify where you either have 0 in the numerator or the denominator, draw the sign chart, plug in the points. You can decide where it's positive, where it's negative. Here is another. This one, instead of being positive, it's negative. We're looking for less than or equal to 0, right? So here, I have to factor the denominator, x plus 3 times x minus 3. And if you look at it, the critical numbers are minus 3, minus 1, and 0, and also 3. So, and even though there's a square upstairs, since there's also an x plus 3 downstairs, every factor has odd order. So we always have a sign flip at each critical number. And then I just plug in, I think about plugging a number in like 4. If I put a 4 in here, every term here is positive, so I get positive. And then I flip from plus to minus, minus to plus, going across like that. I'm looking for less than or equal to 0. This time I look for minuses on my sign chart, right? And so that's just here and there, right? So I do minus 3 to minus 1 and 0 to 3. I include minus 1 because why? That's in the numerator, right? That makes the numerator 0, which is fine. I have to exclude minus 3, 0, and 3 because while minus 3 is also in the numerator, the fact that it's in the denominator is the deal breaker. If you have a 0 in the denominator, game over, it's not part of the domain. All right? So I have to exclude minus 3, 0, and 3 here because those all make the denominator 0. The next one has completing the square in it. So notice that x squared plus 4x plus 5, when we complete the square, that's x plus 2 squared plus 1, which is never 0. That's prime. So that thing just stays there and stays positive all the time, all right? And then the denominator factors to x minus 6 times x minus 7. Critical numbers 6 and 7. If I plug in a point like, I don't know, 10, you can easily see that this is positive. It flips signs at the 6 and the 7, so we get plus, minus, plus like that. I'm looking for where it's greater than or equal to 0, so I look for the pluses. I go minus infinity to 6, and then 7 to infinity. Both 6 and 7 have to be excluded because they both give division by 0. All right. Another one of these. It's endless. So, all right. This time, annoyingly, it has not been given to us to be greater than or equal to 0, right? We have to do some algebra here to make it so. So subtract that fraction to the other side and make a common denominator. Simplify it. It gets us to this. So it turns out my critical numbers are plus or minus the square root of 6, minus 3, and minus 2. I make my sign chart, and I'm looking for where it's positive, right? So that gives me here, here, or here. So I go minus infinity to minus 3, minus root 6 to minus 2, and then root 6, then root 6 to infinity. I have to do a little numerical work here, otherwise it's not entirely clear, but the square root of 6 is about 2.45. That's kind of important because that helps you see where to put it, right? It's between 2 and 3. That's why I have to put square root of 6 minus square root of 6 here, as opposed to, say, on one side or the other side of 2, minus 2 and minus 3, you know? And again, I exclude minus 2 and I exclude minus 3 because those have division by 0. I'm including plus or minus the root of 6 in the solution set because those make the numerator 0. This one's a little bit harder though, right? Yeah. It had some algebra in it. And it also had square roots. Oh no. So we have talked about these problems before. Anybody want to, do I need to review again, or are you guys fine with these ones? So we did number 6, we did number C in class. I'll just talk about, let me just talk about at part A here. So the square root of 25 is square root of 25. Square root of 8, the cube root of 8 is cube root of 8. And then when I take the square root here, I have the square root of x times the square root of y cubed, but the square root of x is x to the 1/2. The square root of y cubed is y to the 3/2. All right? Now downstairs, I'm taking cube roots. So I have x to the 2/3, x to the 5/3. So I usually do these kind of problems in like a two-step process. I first of all like pre-process the numerator and I pre-process the denominator to try to make them like a little bit more well, granulated or something, like piecewise, you know, simplified a little bit. And then what I do is I just use this rule that if you have a power in the denominator, it's too bright. Yowzers.
You good?
Yeah. Whoa. It's not good. It's not good. I was working too hard on something yesterday and my eyes started like not focusing. So I'm trying not to have that happen again at the moment. Because I don't have the only way I can make that stop is with my glasses, which I don't have at school right now. So if this happened, I would have to call my wife and say, I need you to pick me up. I can't drive home. Drive me home for exchange on the A on the test.
I'll take you home right now. Oh. That's crazy. That's crazy.
I just.
You can't drive. You're blind.
Is this an example of students talking? I don't know.
Are you accepting?
No.
You guys.
No. I just had my Title IX training. I feel like there's something.
I saw you last week on your bike.
Oh, really?
I would fail.
It made you happy? Well, you're welcome. Let's see here. So 1/2 minus 2/3, right? 3/2 minus 5/3, because the y to the 5/3 is in the denominator. And then I do arithmetic. That gives me minus 1/6, and that also gives me minus 1/6. So there we have it. A is minus 1/6, B is minus 1/6, and apparently C is 5/2. The cube root of 8 is 2, right? Because 2 times 2 times 2 times 2 is 8. This one, 39 over 13 is 3. I've got x to the minus 1, because x over x squared is x to the minus 1, all right? And then I've got y to the 1/2 upstairs, minus 1/3, because we got a cube root downstairs. That simplifies to a 1/6. So here we got a equals minus 1, b equals 1/6, c equals 3. And then we talked about c in class before, so I won't belabor it. I will post this, guys, once we're done here, you know. Problem 43. So what you do is isolate the radical, all right? And then square both sides. So I isolate the square root of x minus 3, square both sides. Now so guys, listen please. There is a cross term here. You actually need to multiply this out. The mistake all of you make. Okay, not all, but many. Historically speaking, a majority of this class makes this mistake, is that when you square this, you don't really think through the squaring. Because you have to multiply it out. You have to FOIL it out, right? There's first, outer, inner, last, right? I mean, there's 25 from the 5 squared. There's an x squared from minus x times minus x, right? But there's also a minus 5x plus minus 5x from the middle, which gives us this minus 10x. This minus 10x must not be neglected. To neglect this minus 10x is to neglect 2/3 of the credit on this problem in your test. So don't do that. I have enough points. I don't want any more. Please keep your points. I don't want your test to be pointless. So, sorry, that was horrible. But I stand by it. I'm still waiting for my next batch of jokes from my nephew.
Oh, yeah.
He's giving me a few more. I think I already told you these most recent ones. Like the Walmart joke. You remember that? It's not good. Anyway,
Oh, yeah, it wasn't Home Depot.
yeah, it should obviously have been Home Depot, right? I mean, it was just obviously Home Depot, right? Where's the house shop? I mean, Home Depot, clearly, right? All right, anyway, so I factor. I get 4 or 7 for answers, but 7, when you plug it in, it does not work. So 7 is extraneous, so we just keep 4, all right? As a general point of order, whenever you square an equation, you need to check your answer, because the process of squaring can adjoin new solutions to corresponding but different equations. So like when you square the equation, you could be changing the solution set. You could be enlarging the solution set because you're squashing a minus. All right. This one here, again, isolate a radical. I chose to isolate x squared of x plus 1. There's another way to do this problem. You could isolate the square root of x minus 4. That would not be wrong. You square both sides. Again, here, you have to think through multiplying this out. You guys, a lot of you, if you're not careful, you'll forget that there's this term right here. That matters. That's part of the squaring, all right? So when we FOIL it out, we get 25 minus 10 times the square root of x minus 4. And then the square root of x minus 4 squared is just x minus 4. This cleans up quite a bit, because if I bring the 10 times the square root to the other side, the x's cancel. See this? Here and here, x's cancel. We get 25 minus 4 is 21, minus that 1 on the other side gives me a 20. Then I divide by 10. I've got my radical isolated, square both sides, add 4 to both sides. I get 8. Now, I squared this equation, right? So I should check. It could be that this is not actually even a solution. There are problems like that. Yeah.
Would you put no solution if the solution you got was squared?
Yeah, if this one doesn't work, then you say no solution. That's right, yeah. See, this problem is extraneous. No, sorry. Let's see here. This one's a little bit friendlier. You just square both sides. When we square, property of the square root I should mention for you guys. If we have the square root of a over the square root of b, it's equal to the square root of a over b. So this I'm implicitly using as I work this problem here, because I've got a square root upstairs, I've got a square root downstairs. As I square, if I think about it, I can combine them, right? And then when I square both sides, the square root goes away, and I'm left with x plus 2 over 4x plus 1 is equal to 2/3 squared. Well, 2/3 squared is 4/9. At this point, I cross multiply. I get 9 times x plus 2 is 4 times 4x plus 1. And then multiply it out, collect your x's all on one side, divide, you get x equals to 2. And you can try it out, it worked, all right? This one, watch out, not everything's a square, right? So there are also other powers involved. A cubic equation in some sense is easier, because when you cube an equation, you're not changing the solution set. So the extraneous thing won't happen for these ones so much. It doesn't happen here anyway. So when I cube both sides of the equation, that gets rid of the cube root. The natural enemy of the cube root is the cube. So if we cube a cube root, we're back to the inside. In this case, the cube root of 3x squared minus 2x, all of that cube just gives me 3x squared minus 2x. Now, if I ask you to solve a cubic, right, the only way that that's really fair on a test in here is if it just has like an obvious factor. This is one of those, right? Because the obvious factor here is what? X, right? We can factor an x out. So we should be aware of that. And once I factor x out, well, then I've got a quadratic, and at that point we own it, right? Because any quadratic we can factor, either by elementary algebra from like prerequisite courses, right? Or by completing the square if that goes sideways. So I get x times x minus 1 times x plus 2. So I get 0, 1, and minus 2. You can check. Those will all work. Like if you plug in 0, you get 0 equals 0, right? Try plugging in 1. What happens? You get 1 is the cube root of 1. What's the cube root of 1? It's 1. 1 equals 1. Ray, it worked. Plug in minus 2. You get minus 2 is the cube root of what? 3 times minus 2 squared is 12. 12 minus a minus 2 is 16. Wait a minute. Uh-oh. Dummy. Me, not you. What's that? Creef. Well, I'm glad I checked my answer here, because it's wrong. Where's my mistake? Right here, right? That should be a minus. So the solution should be positive. If you try plugging in 2 into that, it'll work, because you get, oh man, you get, you get 3 times 4, which is 12. 12 minus 4 is 8. The cube root of 8 is 2. 2 equals 2. Woohoo! Works.
But the reason that it stays a negative 2 is because you're subtracting the entire function. You're subtracting 3x squared minus 2x.
Wait, you're saying, which, I'm sorry, I'm, what's your question?
So when you set it equal to 0, it is because you are subtracting that function from both sides.
Oh yes, yeah, I'm putting all the x's on one side, yeah.
Right, but it's, you move that as an entire function, right? So that's
Yeah.
why the sign of the 2 doesn't change, versus subtracting 2x squared.
Oh, but, well, I think of it this way. I subtracted 3x squared from both sides. I added 2x to both sides.
Right. So why is it not positive 2?
Oh, that is, no, this is right. This is plus 2. What's wrong is the factoring. See, when I multiply this out, I would get a minus 2. So it's supposed to be x minus 2 here. That's the mistake. I will fix it before I post it, guys. So it'll be a little bit before I post the solution, because I want to, finish the solution here before I post it. But this one's interesting. So x over the cube root of x is x to the minus 2/3. All right. How do you solve an equation of the form x to the minus 2/3 equals to something? What you do is you take both sides of the equation and you power it to the reciprocal of minus 2/3, which is minus 3/2. So if I take both sides of the equation, I raise it to the minus 3/2 power, these cancel to give me power 1, which is just x. X to the 1 is x, right? And then I got pi to the minus 3/2. Now pi to the minus 3/2 is just a number. You could rewrite it. It's 1 over the square root of pi cubed. I mean, is that better? I don't know. This is a perfectly good answer. It's approximately 0.7196 for what it's worth. So, of course, I could make this more friendly by changing it to some number you can calculate the exact 3/2 power of, but yeah.
If we had just x equals pi to the negative 3/2, would that be full credit? Or do we need
X equals to pi to the minus 3/2, would that be full? Yes, that would be full credit. It's in the box. Yeah, yeah. Generally, if I box stuff, like anything that's in the box is like a legit answer. This one here, problem 48, you want to make a substitution. So what you do is you let y equals to 1 over the square root of x. If you do that, then y squared is 1 over x. All right? And so then the equation which is given becomes y squared minus 3y plus 2, which factors to y minus 2 times y minus 1, like that. So either y equals 1 or y equals 2, which undoing the substitution gives me 1 over the square root of x equals to 1, or 1 over the square root of x equals to 2, which I then solve for square root of x, isolate the radical, right? And then I square both sides. That gives me x equals to 1 or x equals to 1/4. So there's your solutions here. Any questions about that one? This one's a little bit trickier, right? I mean, so this one, if I was to give this on the test, I might also have like a little hint. I might say hint, try a substitution, perhaps, something like that. I might say hint, try y equals 1 over the square root of x. See, but this is where I start to get into trouble, because when I write hints, they can sometimes be like misinterpreted if my wording is just off from whatever your internal like narrative is. And so I've grown distrustful of hints. Many a time I've given a hint on a test which has not been a help, it has been a hurt. So, I don't know. I'm leery of hints. Graphs. We love graphs, right? So if you look at old tests that I've showed you, a lot of times I like to ask the test in a multiple choice format. So like, here's 4 formulas, pick the matching graph. I like that format because it frees me from the trouble of critiquing your graphs, which is not something that typically gives me joy. As not many of you are art majors, and if you were an art major, you'd probably add a turtle to your graph or something, I don't know. But you will not get extra credit if you draw a turtle. I will be amused, but it will not change your score, probably. Except it might make me in a general overall temperament, and then I would grade the whole class more generously or something. So it's possible that you're contributing to the greater good by drawing a turtle on your test. However, if you spend 20 minutes drawing this turtle and then you have other things on the test left blank and then tell me ran out of time, that will decrease my morale.
What
Yes.
if we do Batman? Or like,
Same principle applies to Batman.
but you are
Which Batman are we talking about? Are we talking about like
whichever one will give you.
which whichever one will give you points? You guys cannot trick me. Class does not end at 150. Class ends at 2 in here. I'm quite certain of it. There is like this, you guys as a group start packing bags at like 8 minutes before the classes end. And is there some kind of is there some sort of group chat in here I don't know about or something? It's like, all right, everybody, pack your bags. Let's mess with his head. Mission accomplished. All right, let's see here. Anyway, so here's the next one. This is y equals 1 over x. And we shift it 2 to the right. That's it. So listen, on your formula sheet, I would advise you putting the graphs of all of the basic functions, right? Like x squared, x cubed, square root of x, cube root of x, 1 over x squared, absolute value of x, right? All of these basic functions, if you have a picture of it on your formula sheet, well, that should be really helpful because then you could, that gives you a sense of what it should look like approximately, right? Here's 1 over 1 plus x squared, Well, honestly, even just putting these answers on your formula sheet as just a bank of examples might be helpful to you. I don't know. This one we already talked about in the previous arc of the course, right? This is a parabola. The vertex is at 2, 3. So there you have it. The range is 3 to infinity. The domain's everything. This is a cube root function, which is like a cubic function turned sideways, all right? It goes on in both directions. So its domain and range are both all real numbers. This is the absolute value function turned over upside down, shifted up 2, moved over 3. So the range goes from 2 at the maximum all the way down to minus infinity. The domain's everything, but that's the graph of this. So absolute value functions should look like a tent, basically, either going up or going down. Piecewise defined functions are challenging, but you can do it. You just have to understand they have 2 pieces, right, or more, and you have to follow the instructions for each piece separately. So like this one, if x is less than 1, you're looking at x squared plus 3. So that is a parabola which has a y-intercept of 3, right? So it looks something like this. And it's open because it's not defined at 1, right? At 1, it jumps to the x cubed formula. What happens when you cube 1? Well, you get 1. So this point right here should be at 1, 1. If I labeled it, it would be better. Oh well, I forgot. And then it's a cubic, so it kind of goes up and up and up like that. So what's f of 0? Well, f of 0, I use the left formula, right? I'm going to use the lower formula because x is less than 0 is less than 1. So I do 0 squared plus 3, which is 3. 2, well, I have to use the other formula, see, because 2 is greater than 1. So I have 2 cubed, which is 8. And If you look at the graph, right, you can see that the range is everything above 1. Right? Well, you missed this point here, right? But you picked it back up over there. So everything above 1 is covered for the range. This one here, a little bit tricky, but the square root of x minus 1 squared is the absolute value of x minus 1. So that's either minus x minus 1 or plus x minus 1 if you're either before or after 1. So when you plug that into here, it simplifies. It's either 1, or minus 1 rather, for x less than 1, or it's 1 for x greater than 1. F of 1 does not exist because you have division by 0 there, but that's it. Like, that's the nice simplified formula for here. Problem 52 is important. There's a couple different ways to think about problem 52. Well, although problem 52 asks you to do it algebraically, okay? So algebraically, you can try to decide whether or not an equation defines a function by just solving for y. If you can solve for y uniquely, then for just a single formula, then y is a function of x. When I do that here, though, what happens is I have to take the square root of both sides, at which point I introduce plus minus, right? So I get y is equal to 1 plus or minus the square root of 4 minus x squared, which means that there's not a single function of x, but rather two functions of x, so that's not a function, right? Because a function has to be single valued. You're saddled with a plus or minus here as you solve the equation, so you're stuck with not a function. Now the reason for that, if you want to think geometrically, is what we're looking at is the equation of a circle centered at 0, 1 with radius 2, like this. And that circle fails the vertical line test, right? So that's another thing that might be in your test, is vertical line test. Here's a graph. Is this graph of a function? Well, if it fails the vertical line test, then no, right? But this problem here was the algebraic. Yep.
For the questions where we were supposed to put the equations into Desmos and sketch them,
Yeah.
are you going to be graded on our ability to make an accurate sketch? Or is it just like if it's kind of close?
If you've done something, you'll get credit.
Sweet.
Yeah.
Because I was really bad at like drawing the oval.
Well, yeah, I mean, they can be kind of ugly, right? Let's see here. Where are we at? There was a Spider-Man logo? What have I done?
The second one of the Desmos. Oh, yeah.
Let's see here. Oh, that one?
B was the Spider-Man logo. And A was the oval that I like.
I just need a nose ring to kind of like, that's a whole fit together. Like some nails too.
Oh, man. Well, that is not helpful.
Oh my goodness.
I was trying to be lazy and copy and paste, but it didn't do it for me, did it? Let's see here. It was supposed to be, what was it? X squared. So what should happen here is we should have a circle of radius 3 that's part of the solution set. And then also something funky.
That's the Spider-Man.
I don't even know I don't know what x to the 4th minus y to the 4th looks like, but it's yeah, that's the Spider-Man logo. Huh.
It's like a minimalist logo. It's like a formula.
Cool. Well, guys, any other questions about the test? No? All right. Well, see you Thursday.
Do you quiz this 6 back or do you have a recorder?
You can keep it. It's fine.